Hello, my name is Christian. We are at AGRO-MASZ headquarters, and today we continue the presentation of the Runner 30 no-till aggregate for you. In the previous episode, David presented the machine from a technical side, the working widths, the possibilities of machine configuration. While today we will focus on things that are not visible at first glance, but are a very important part of the machine's work. That is, we will focus on the heat treatment of individual elements, how the individual elements are produced at painting, and other aspects that make the whole machine look like this. Currently, we are in hall number 6. Behind my back in a moment, the process of bolt carburizing will begin, which are mounted in the leg in the cultivation unit in the runner. Why do we do this? We do this so that while maintaining the appropriate parameters of the screw core, that is, we keep the cores at the optimum hardness so that the screw does not break. We can carburize the screw on the outside with this very atmosphere, which now comes out of the furnace when opening the door. This atmosphere makes the outer shell of the screw is carburized, so that its hardness is about 64 HRC at the depth of 0.1 to 0.2 millimeters, depending on the parameter. Thanks to this, the screw is very resistant to abrasion, and thanks to all the working elements, have a larger working surface. Behind my back there is an induction hardener. Not every part is suitable for full hardening in the gas furnaces we saw in the previous shots. Therefore, for parts that are welded and thus at the point of welding cannot be hardened, that is why we use an induction hardener. Here in my hands, I am holding a component that is one of the main parts of this whole pump, which holds the springs in the mechanism that secures the whole claw. As you can see, the whole opening here in which the screw works, that rotates on the screw, is induction hardened. Thanks to this, we have a very hard surface, and it is much more resistant to wear and abrasion. All these processes we're talking about would be useless if we didn't constantly check how they are running, what their results are. So we are consistently conducting quality control of gas-hardened or induction-hardened or carburized elements. We have a special laboratory for this on the premises of our company, where we can prepare special samples using special equipment. We can measure exactly the hardness over the entire cross-section of our element. Therefore, we have a constant overview of what parameters our elements have and what we need to improve continuously to maintain such good quality all the time. Currently, we are in hall number 8. The hall was built in the last 2 years. We launched here an automatic line for RAM welding. We will also go here to show you what it's all about. The whole frame is put into the die. Then the robots weld every single welded element automatically. Therefore, we have a very high repeatability. The welded elements are placed very nicely, but it's not all about aesthetics, because it's primarily about robust melting into the material. Thanks to robot welding, we always have the same parameters, the same method. Also, these welded elements are connected uniformly and accurately. Let's go to see how it looks in practice. In addition to the large cells we have just mentioned, there are 5 smaller cells behind me for smaller welding tasks. On the first one, we are surfacing working parts for our runner. In my hand, I'm holding on my left side an already surfaced part. On my right side, a part before surfacing also. As David mentioned earlier in the episodes, we have a choice of different workpieces, either surfaced ones with higher strength, which can be used for much more hectares, or standard ones, which are in our offer in the basic machine version. Let's move on to the stage of painting and galvanizing, which are the two main cycles that are used to protect our machines from corrosion and make them look aesthetically pleasing. Behind me right now, there is our flake galvanizing. What is it basically? We won't go into the details of the full technological parameters. The most important aspect of this is that the flake zinc, which is actually applied to this bolt at good parameters with an appropriately selected process, is able to last 5 times longer in the salt chamber than ordinary galvanized zinc. Also, such a bolt, which I am holding here, can easily last in the salt chamber for more than 1,000 hours, which equals even more than 10 years without any rust spots on such bolts covered with flake. Zinc. As I mentioned during my visit to the galvanizing plant, we standardly protect the surface in our company in 2 ways. Small elements such as pins are protected by flake galvanizing, while all other elements such as the frame or small parts such as the beams are protected by powder coating. Behind my back there is one of the 3 painting lines that we have in our company. It's a line for small elements specifically, which can work in continuous mode, so the feeder goes all the time without stopping, and we only add and remove completed elements.